back to Maths with Mrs. J. We're partway through a sketch of a rational function. I decided to break this up into two separate videos because it was becoming a very long video and I just wanted to sort of make it a little bit more palatable for you. In our previous video, we sort of did the hardest part of it. The intercepts are obviously easy to work out, but learning about how to work out asymptotes is the tricky part. Just to remind you, we found that we had a vertical asymptote at x equals 4. There were two criteria that we needed to satisfy in order for that to actually be an asymptote. Certainly, we needed to know that the function was not defined for x equals 4, which clearly it isn't, because if x is 4, then the denominator would be 0. But in addition to that, we needed to know that as x is tending towards 4 from above and as x is tending towards 4 from below, that we were tending towards either infinity or negative infinity either way, that we were not tending towards the same actual number. And clearly in this case, it did categorise as a vertical asymptote. Our oblique asymptote we got by doing a long division and then looking at what happened to the fractional part of that expression as x tended towards infinity and negative infinity. And we found that as x got really, really big, we tended towards that line from above. And as x got really, really small, x tended towards that line from below. Remaining for us to do now are to find the stationary points in their nature, any potential points of inflection, and then obviously to put all this information onto a graph and get a bit of a sketch happening. So our stationary points, I'm going to use the version of the function where we had our x minus 1 plus 2 times x minus 4 to the negative 1. That's nice and easy to differentiate. So f dash x, well, this will just be 1 when you differentiate it. Negative 1 will be nothing. So we're going to get minus 2 to the x minus 4 to the negative 2. The inner function here just has a derivative of 1, so the chain rule isn't even really necessary. So we've got 1 minus 2 over x minus 4 squared, which is all over x minus 4 squared, x minus 4 squared minus 2. So that's going to be 0 when the numerator is 0, so when x minus 4 squared is 2. It's easier to leave it in this version because we've already got a completing the square situation. So we're saying x minus 4 squared is 2. So x is obviously, well, x minus 4 is plus or minus root 2. So x is 4 plus or minus root 2. Now we do want those exact values, but it would also be helpful for us to have an approximation because we do need to know roughly where to put the dots on the graph. All right, so the bigger one of those, 4 plus root 2, is approximately, I think we get 5.41 for that, for the bigger one. And for 4 minus root 2, we get about the 2.59. But these are the exact values and we should actually work with those when we're substituting in. So let's find our relevant y values. So f of 4 plus root 2, just subbing it into the equation, probably our original equation where we had our f of x is x minus 1 plus 2 on x minus 4. That's a good one to sub in. So obviously we're going to get 4 plus root 2 minus 1 plus 2 over 4 plus root 2 minus 4. Now the 4's go. 2 divided by root 2 is root 2. So you're going to end up with 3 plus 2 root 2. And again, having an approximation for that would be helpful. That is approximately 5.83. Let's do the other x value. Let's sub that in. So 4 minus root 2. Again, it's going to work out quite nice and easily. So 4 minus root 2 minus 1 plus 2 on 4 minus root 2 minus 4. So we're going to end up with 3 minus 2 root 2 is the exact answer. So that's our exact answer. But an approximation is about the 0.17. So we know that we've got stationary points at 4 minus root 2, 3 minus 2 root 2, and at 4 plus root 2, 3 plus 2 root 2. And they were approximately the points 2.59, 0.17 and 0.41 and 5.83 as the y value there. Okay, so that's useful information, all right? That's probably what's going to help us on our graph. Determining the nature of the stationary points and any potential points of inflection, let's go back to this version here. We had, so let's just do nature here, our little title. So f dash x we said was 1 minus 2 x minus 4 to the negative 2. So when we differentiate that, derivative of 1 is nothing. I'm going to get negative 2 times negative 2, which is 4, x minus 4 to the negative 3, and that's 4 over x minus 4 cubed. Now that is never going to be 0 because it would only be 0 if the numerator were 0. 4 is 4, okay? It's never going to be 0. So no points of inflection there. We can check the nature of these stationary points. So f double dash at 4 minus root 2 is 4 over 4 minus root 2 minus 4 cubed. Now that's going to be, well, they'll cancel out. You've got a negative cube. We're actually going to get negative. So it's concave down. So that's a local maximum there. At the other x value, at the other stationary point, when we sub in there, we're going to get a positive answer. So it's concave up, so that's a local minimum. So we've determined the nature of those stationary points. One of them is a local maximum, one is a local minimum. There are no points of inflection in this particular situation. We're now just about ready to pop all that vital information onto a graph. So let's just go on to our next slide and we'll do that. I've ruled one up in preparation just to make things a little bit easier. Now, normally we do our asymptotes with dotty lines, all right, but I don't have that facility on this whiteboard. So to do a dotty line, it wouldn't have looked like a straight line, I'm afraid. But this is the vertical asymptote, x equals 4. This is our oblique asymptote, y equals x minus 1. I've also marked in orange, I have marked our intercepts. So our x-intercepts were at 2 and 3, and our y-intercept was at negative 1.5. And I've also put dots approximately where our turning points or stationary points are. So this one is your 4 plus root 2, 3 plus 2 root 2. This is your 4 minus root 2, 3 minus 2 root 2. All we really need to do then is use that information and what we know about tending towards these lines to get a sketch happening. Now, this stationary point was a local minimum. And we know that we're tending towards positive infinity here, and we're tending towards this line from above. So we're going to do something like this. All right, so you want it to be tending towards the line, but not actually touching it. And then down here, we've got a local maximum here, and it's come through here, and it's going to be approaching this line from below. Okay, so down here, we've got our local maximum here. We're going to touch here. So we've got something like that, and then we're going to tend towards this line from below, and we're going to tend towards this line also from below. Now that's not fantastic. It's much easier if you have a pencil to do it, and then you can fix it up if you make any mistakes. But that's roughly our function. F of x is x squared minus 5x plus 6 over your x minus 4. Now, in our next video, I want to do one that's very, very similar in terms of its equation, but has a very different graph.